Hello, everyone. Welcome to Houdini Hangout. It is the 12th of April. Wow. Can't believe it's April already. Um, Heck, we're halfway through April. Thanks for joining me tonight. If you didn't see my posts online, unfortunately, I was out of commission with COVID last week. So that was a lot of fun. Both me and my wife were hit with that. So that was it's a particularly interesting week in our household. Um, Not particularly fun, but we made it through and we're doing a bit better. Still a little tired now and then, but for the most part, doing pretty well. And the wife is also recovering pretty quickly. So, all things considered, we're doing well. But yeah, so I don't have anything too um, specific tonight that I'm going to be working on. I kind of was hoping that maybe I would get a couple suggestions from out there, but I didn't see anyone post anything in response to my message. So um, I am kind of just going to wing it a little bit tonight. I have a couple ideas of things that we can do, or at least an idea of something that we can do. Um, and we'll try to get through it. My apologies if I have any little coughs here and there or whatever. Please understand that I will try to keep that to a minimum. But coming off of a sickness, you sometimes have a little bit of a cough. So, um, nothing. Hopefully, nothing too crazy. Houdini's yelling at me already to save. Sure, I'll save real quick, Houdini. No problem. Let's see. Where does this stuff even go? So tonight, I think I'm going to do just like a little RBD collapse type thing. So let's give that a shot. We'll do some RBD stuff tonight. Why not? So yeah, so I hope you all out there are having a great evening. Um, I brought in a couple things of geometry here that we could possibly start off with um, for our effect. There is a rhino, a couple different sculptures that I found on, I think it was on 3dscans.com or whatever. Mr. Napoleon here, but I think I want to work with the rhino. I think that seems fun. Seems like a fun model to work with. So I think we'll go with the rhino tonight. I also have updated my background to be the this lovely shade of gray. If you're liking it or not liking it, let me know in chat. Um, Let me know what you think. This is the new Side Effects Labs gray background. If you're interested in it, make sure you've got your Side Effects Labs stuff installed, and then you can go to Preferences and just check on Viewport Alternative gray background right here, and accept and apply and all that stuff. And I think when you restart the program, it will bring that up. So I'm giving it a shot. See what it's like. Seems a little bit more subdued and kind of nice on the eyes. So if it's working for you, great. If not, let me know. And as always, please let me know if you have any suggestions, comments, questions, think I'm doing something the dumbest way possible, or really like the way I'm doing something and just want more information, just drop it in chat. Love to hear from you guys if you're, if there's anything helpful that you can think of to add to the conversation. That's what this whole thing is about. It's about having a conversation about Houdini and not just me sitting here and yapping at you the whole night. So, yeah, join in chat, drop your comments in there. And, yeah, if you have anything you'd like to add, I'd love to hear it. So, so what I'm thinking we could do here is do a little like a crumbling RBD type setup here. So a little bit of just some custom, constraints and things like that. Nothing too intense, but just something fun to get the juices flowing and get us kind of back into this after I've been sitting on the couch for a weekish now. So yeah, why don't we do that, and we'll see where we go, see where we get. Okay, so I have this model here. It's obviously extremely highly detailed. It's a pretty crazy mesh because it's a scan. So we can see here that there's quite a bit of geometry, quite a bit of stuff happening here. Um, I'm going to try to reduce this, do a poly reduce on it. So since we're doing this, why don't we just, I'll just get rid of this other stuff here. We don't really need that. So let's do that. Great. Line it back up. All right. So we've got our, so basically all I did is imported it, transformed it so it was right side up. Where are we? There you go. And then just did a match size to center it on the ground plane. All nice and good. So let's see, how big is this thing? Yeah, this thing's pretty gigantic. Why don't we scale you down a little here, bud? So I'm just going to do that with a transform. Could do it with the match size as well, I guess, but why don't I just do 0.1 and we'll get it to maybe a little bit more of a realistic size here. We don't want it to be too gigantic. In fact, let's see where that gets us. Couple meters. That seems fine. That's still pretty gigantic, but it'll be reasonable. Reasonable and large, no problem. All right, so let's do that. So right now we've got it at, several meters across in this axis, or maybe that axis. I'm not sure. Which one is it? It's in the Z. That's our biggest one. Great. So let's do a poly reduce. See if we can get some of the polygonal amounts down here a little bit. So this is analyzing right now. I'll give it a second. Let's just see. Let's see what half gets us real quick here. Let it reduce. This will take a second, but usually once you've done this, run a couple step. I think usually once you've run it through once, it gets a little quicker the next time you do it. I think there's a couple initial calculations it has to do. All right, we're down quite a bit, but we still, I think, could go quite a bit less. Let's just see what happens if we reduce it within the tolerance here. It's kind of an interesting way to do it. It'll kind of keep going until this tolerance threshold is hit. So let's see where that gets us. You can see here, can you see here? No, I don't think you can actually read that out. Wow, that's way too much. You can still see them, but that's way too much. So if you look right here, there's a tolerance value, and you can adjust this. So I'm just going to do this to the -6th. Okay, there we go. That's going to be a little bit better. So this basically will allow us to control by like a quality threshold. So we can go in order of magnitude here. Maybe point, to the -0.7 will be good. That seems pretty reasonable. We'll see how that goes for us. It started off at, let's see here. It started off at about 2.8 million primitives, and now we're at 450,000. So that's a pretty good reduction. I'll take it. So why don't we try using a material fracture? Let's give that a shot. Actually, I'm just going to do a null here. I'm going to do that all in its own node so that we're not doing it here. So let's just do this, call this out, and call this geo source. Should have named that properly first. Now it's got to do all that calculation again. Whoops, my bad. There's a little pro tip: name your geometry nodes first, because otherwise you have to sit and wait for it to recalculate. Unless you've cached it, of course, then you wouldn't have to. Which I probably should have done as well. Kind of a nice thing to do from time to time. All right, there we are. We're back in business. All right, so there's our geo source. Let's just do another geo node. We'll call this SimRBD. Got purple. Let's jump inside here. All right, so let's object merge in. So let's get source geo. And let's grab that. And now let's do our RBD material fracture. Let that calculate up. See what we get here. So the RBD material fracture is an interesting node. It's kind of got a whole bunch of things mixed up inside of it. Does some Voronoi fracturing in there. You can set, um, custom points to be able to fracture by, things like that. So let's see where we get here. All right, cool. Looking good. Looking good. So we've got our material fracture there. And in fact, what we could do here, now that I'm thinking of this, well, let's do this. Let's do an RBD exploded view. Drop that on here. Just take a look at how that is here. Let's hide the other geometry. And there we are. Yeah, we got some fractures and stuff there, looking cool. Just going to scale that down a little bit. Yep, so there's our fracture. It's kind of a weird look with that white, with the white lines on it like that. I wonder if... Oh, it's the proxy geometry. That's what it is. All right, let's go back. Let's go back to our gray. So the reason that was white was because it was using the same proxy geometry here as it was for the basically it's using high res and proxy geometry are exactly the same. So they're kind of sitting on top of each other like that. So that's why I'm getting that white, like so. You know what I'm kind of curious of is, let's just try something here. Let's come back up here. Let's do this. Let's call this out proxy. And let's take another null here and do high res. See if this will work. Not 100% sure, but give it a shot. So this should still be looking at the proxy output. But what I'm wondering is if we could do this, because this has a proxy geometry input. So I'm kind of thinking that we could do this over here. And then if we do the same thing, get source, we'll call this get proxy. And this high res. I wonder if this will give us what we want. So this would actually be the one that has a lot more resolution to it. This, oops, no, incorrect. Didn't change that. Oh, high res. So this will be the high res geometry here. And then this would be the proxy geometry. So what I could actually do, I wonder, let's see. If this is the case, I can reduce my, the amount of reduction that's going on the proxy geometry, and that'll give us a little bit of a higher, a little bit of a quicker sim with everything, because it's not going to be having to calculate so much for the collisions. So let's see where this goes. See if this works. What I'm hoping it's going to do is take both of those, embed the high res and the proxy together. Not sure if it'll work or not, but hey, give it a shot. That's what this is about: experimentation and learning. So let's see what we learn. Looks like it's taking quite a bit longer, so that is making me think that it won't be doing that, unfortunately. So let's see. Let us see. So we can use this RBD exploded view. Well, does actually look like it's doing what I was hoping it would do. Yeah, so you can see right here, we've got lower resolution proxy geometry, higher resolution geometry that was captured. Um, and when we do our simulation, it will do it on the proxy geometry. So that's cool. All right, let us. Well, I still don't think I need that much. All these little tiny nonsensical areas here. So let's just adjust this a little bit here. Let's go back up to our source. So this, instead of it being our proxy, let's just set this one to be this. Now they're the same for both. And then our proxy can even be more reduced. Give that a second there. And I'm really gonna let this kind of reduce quite a bit. You know, basically to the point at which we still have the overall shapes, but they're really just low poly representations of those shapes. So that we're not losing the collision geometry that we want, but it'll certainly simulate a lot quicker that way. So let's do this. Let's try this down to, let's go back to 6 and see where that gets us. That's pretty good. I'm going to look at this one and just have this wireframed like that. You can kind of see that other lattice on top of it there. Let's do, maybe we can do 6. I think, does that work? Maybe not. Thought I could type in 6.5 there. Maybe not. Maybe not. Seems to think that that was a some sort of a expression that I was typing in there. Go. Sorry. Still reducing here. Fortunately, it takes a little bit of time. All right. Ah, I see the problem. I set them both to the same thing. Let me undo that. My mistake. There we go. 7. This one's at 6. Let's try 5. See where that gets us. That's too much. Let's just do 6. I think that'll be good. Got a little bit higher resolution there. In fact, we could probably go even just another step up with the high res like that. That'll be quite a bit less. It'll just be 50% of the original. And this will be considerably less for our proxy geo. But it seems like we still have the nice shapes there overall, so we'll call it a win. All right, so we got proxy and some high res. Let's go back to our RBD over here. It's going to do all the calculations and things like that while we get to this level because it's visible. So I will let that fracture it. There we go. Cool. All right, so we can see our high resolution geometry with the low resolution proxy on top of it there. If we want to, we can also show our constraints, and I think that will show the constraints that are between these geometries. Sure does. If I make that a little bit bigger here, we'll see all those constraints in between, like so. There we go. So we can see what's going on there. Let us turn those both off. And let's go back to this material fracture. Let's just check how the naming is going here. Going to let that rename these pieces. And so what we've got here is we've got two fracture levels. So that's causing it to have one first kind of big overall fracture and then a second fracture of those original big pieces. So what I'm going to do first is I'm just going to turn off, I'm going to disable the secondary fracture and just look at the first one. I did not, shouldn't have even done that. I'll just leave it the way it was before. Let's see, I think I can do this here. Sorry, just trying to remember how these naming things work. Believe I'll set this to kind of give it a unique name. I'll call this guy Rhino here. And actually, while I'm at it, I'm just going to stop that and turn off the secondary fracture because we don't need to worry about that just yet. We'll look at it kind of one piece at a time, or one fracture level at a time. Right, there we go. So this should just have like 5 pieces, I want to say. Yeah. 1, 2, 3, 4, 5-ish, roughly. So here's our primary fracture. We've got 5 scatter points. We have a fog volume that's we're using to get that to scatter into. So we've got our fracture piece 0, 0. We'll just call this Rhino. Go, Rhino piece. And then, yeah, so let's actually have some more top level fractures of this. I think that would be helpful. So let's do this. So we'll take this up to, I don't know, let's do like 10 fractures at this first level. So we'll let that scatter in there, do its calculation. Should probably take about 20 seconds to fracture that all up. All right. That's looking a little bit better. Now we've got a bunch more pieces. It's looking pretty good. Cool. And so now let's take a look at the second level here. So now let's just hold this for a second. I'm gonna set this to manual so it doesn't jump the second I hit this. So we've got a second concrete fracture here, and it's gonna scatter 5 points into each of those top level points. And let's see where that gets us. I think we should be good with everything else here. Yep, I'll say yes. So let's refresh that. Let that calculate up. Let's see where we get. All right, let's see our exploded view here. Oh, let's do this back to auto. So it'll update this view as well. And there we go. We can see all of our pieces here. Looking pretty good. Might even want to do another fracture there as well. And actually what I'm going to do is I'm going to reduce this high res a little bit. It's taking just a little too long. There's kind of no reason to. I think you understand the concept of it. So let's just set this back down to 7. That'll get us our reasonable level. And then this here at 6 will be our proxy resolution. In fact, we might even be able to set that to 5. Be fine. I have a feeling we will be able to. So, and it's reducing. I think that'll work. Let's see. Sure, why not? Call it good. Pretty close. Doesn't seem like it'll be that big of an issue. All right, so let's just jump back up here. Hopefully this will run a little quicker this time. A few less polygons for it to calculate because it is having to fracture. Technically, it's fracturing both pieces of geometry. So it's fracturing, oh yeah, that's way faster. Great. So it's fracturing both sides of it. It's fracturing the high res side and it's fracturing the the proxy side as well. Because you can see here, as you can see here, there's the proxy geometry is also has this cut. It's in the same exact spot. So one of the real reasons that this can be really helpful is if we start to add in things like detail, right? So let's say we do some edge detail here. Let that go. Let's let that calculate real quick here. Well, I don't know how quick it'll be, but give it a few seconds. Can usually tell by my fans on my computer when it's just about to be done. Okay, so there is our edge detail right there. And you can see that it has created this kind of wavy edge to the cuts here. And what you'll see is that the geometry itself has this wavy edge, but the proxy does not. So this is where you get the real savings because instead of worrying about all these points and polys here to do your calculations on, you have one large flat surface that you're doing your collision on. So, you'll never really see that little difference there between those two, especially if you're doing something really gigantic. Now, I guess the smaller and smaller it gets, you could maybe notice some weird intersections or penetrations or whatever, but I really doubt you would see it at all. So let's call that good. Gives us a little more interior interest. You could also turn on the interior detail. Let's let this go for a second. This will take another little bit to calculate. And this should also just increase the inside noise and like tweak that a little bit as well. And that'll give us some little bit of better detailing on the inside there. So the first one really is doing our the first one really is interested in getting this edge here kind of cut a little differently. And the interior detail is more interested in what's going on the inside of this here, at least from my understanding of how this works. So I don't think we need that extra interior detail. We can just call it good. It's not like we're going to be like doing some fantastic render of this. Kind of just want to get something interesting to use here, and then we'll just call it from there. But so let's turn the interior detail off. We'll just have the edge detail, and that should be fine. Give it some more interest when it breaks up so it doesn't just look completely flat. And let's also do one more level of fracture here, I think. So I'm just going to put this back to manual. Let's add another detail of fracture here. And we can just do 5 points again. Yeah, not even. Let's do like 3 points. I just want a little bit more fracturing of some of these pieces. It'll make some of the smaller pieces even smaller, and it'll make some of the larger pieces fractured as well. What we could also do is do we could add in some. There's many different ways you could kind of do this. You could source points in that would locate where this fracture level is going from. We could do a fracture ratio and have it, instead of being 1, we could do it at like 0.5 and do like 50% of them. So, why don't we just try something interesting? Let's do that. We'll do like half of them. Half of them will get 5 more scattered points or fractured points. So let's try that. Might as well. The other thing I'm just kind of thinking through, I'm wondering if there's a way that you could set that with like an attribute or something like that. Like if you measured that, all those pieces or something like that, if you could do it that way as well, but whatever. Cool. So now we've got those pieces there. They're fractured again. See how many pieces we have here. It's an RBD configure. Yeah, that's what we want. Just gonna see how many pieces we're dealing with here. 147. Doesn't seem like too much. Actually, that should not be connected there. My bad. That should be connected. Oh, there's a. What is the. Somebody mentioned this the other day on the stream, and I can't remember what it was. Was it? Thought it was if you hit J and it would connect them all. It doesn't seem to be. It's weird. Anyways, all right, cool. 147 right there. Perfect. So instead of that, let's do. All right, let's change this up a little. How we're doing it. Let's do the initial one. I'm going to set this to manual, and let's just do it like this. We'll do 20, then 10 on this level, and then 5 on that level, and we'll do it like 75%. I'll get that last 5, and that. Thought that worked differently. That's weird. Maybe I have to hold a modifier for that. All right. Let's go back to auto update here and we'll take a look at this. Let that calculate. I'm just going to give it a bit more because 147 chunks feels like not enough to me. Feels like we want more than that. I should have cooking music or something like that. Something that would play here. Not the Jeopardy music, but something of that nature. Dun, 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 dun. Ah, that's not too bad. There we go. That's what I'm talking about. Great. That's a little bit better. That feels a little bit more like a real fracture. Great. All right, cool. Cool. We still have that nice little detail on the inside here. You can see it. Let's go back to here. Actually, if we do that, it won't be packed, so we can actually see the geometry. If you have your geometry packed when you look at it. Oh, hey, thanks. Thanks, Crossfader. How do you... Ah, man, I wish... could you phonetically say how you say your first name? Is it just Lucas with a Z that's silent? Or how do you say your name? I know you're Crossfader as well, but how do you say that your first name? Is it just Lucas? I will await your answer. Wukash. Wow, okay. That's cool. Wukash? Is that how you would say it? Wukash? Cool. Well, thank you very much. I'm glad I could even have a stream. Glad I'm a little bit back in the game here and can get back to hopefully making some interesting stuff. So, yes, thank you for joining me this evening. Have a great night. And thanks for the spelling of your name. I was kind of curious about that. Wukash. Okay, cool. First try. One of my Batman from the Lego movie. First try. All right. Well, let's make this guy do something now. Now that we've got him all broken up. Looking nice. There we go. How many pieces we have? Ooh, 900. Yes, let's go for it. All right, let's do adopt network here. Because I want to do this. I want to do this the old-fashioned way. Let's see here. So we've got... Make sure we've got this all set up. Rhino piece. We got all the numbering set there. Great. you can see down here that when you have it set with those different layers, what it'll actually do is say, like, you've got piece, in this case, we didn't have any pieces that were coming in from the start. So it's piece 0, whatever. That's the top level piece that's coming in. And so, so now we have piece 0 and then, 104 or 100, and that's each level of that fracture. So the first level fracture right here, this column goes all the way up to, it looks like 24 roughly, and then the next one goes to 10 at its highest. Now each piece can have 10, and then from there it has 5 that next one could go to. So that's how that naming gets built up, and that way we don't have any collisions in our naming structure for our RBD simulation. So I'm just going to pipe these all into a DOP network like this. Let's start building this up. Let's do an RBD packed object. We'll do an RBD solver. Is that right? Nope, that's the wrong one. We want a rigid body solver. The RBD solver is like, I think the like base solver that's in here actually, and it's this one, and we don't want to use it. We want to use Bullet technically, which is weird because it's a rigid body solver, but you want to use Bullet, and yeah, anyways, all craziness. Okay, so there's that RBD packed object. Let's do a gravity force. Boom. Let's do a ground plane. And let's do a merge here. Do it like that. Set it up. Okay, cool. So let's point this. This is our RBD packed object. We want to point this where it's coming in, and this is coming in not as a SOP, but as the first context geometry. And there we are. There it is. Oh, actually, in fact, it's technically our third context geometry because that is our proxy geometry. So that is what we want instead. And don't know if we need to overwrite that. Let's just check this here. This should be convex hull. Yep. Physical bullet data. We can check our guide geometry, I guess, real quick. There's our guide geometry. Set up there. Now, oops. And there we go. Goodbye. Let me actually turn this off real quick. I just want to see. I want to see if that tail is actually just one big chunk like that. Oh, it sure is. Look, that's kind of weird. Huh. I would really want that to fracture differently, I would think. But you know what? I am going to change that. Let's just do something here. Let's do our fracture ratio back up to 1. I have a feeling that that piece just didn't fracture in its last fracturing step. So let's just give it a push over the edge. See if we can't get that to break out, because that feels weird having that tail all one chunk like that. Well, okay. Fine. Have your way. Oh, look at that actually. Ooh, we got some weird stuff there. So this is actually what'll happen when you get a piece of geometry that isn't cutting properly. So, you know what? It's fine. I'll leave it the way it was. We won't do the whole thing. 7.5. Let's see. Will that go quick? Wonder. No, too bad. Kind of wish it would kind of keep some of that information in there and it could just not have to rescatter everything each time, but that's all right. I'll take the niceness of, or the convenience of having a node that can do all this stuff instead of and waiting a little bit of time instead of having to do it all by hand. Because basically what we'd be doing here is a lot of for each loops and things like that. So you can see that those cutting geometries went away. Basically that geometry is being created inside of this HTA here, more or less, and it's, you know, somewhere inside of here, in this whole mess of nonsense that's happening. So it's just basically not able to get rid of that cutter geometry that it created in there. You know, let's also do this too. Now that I was thinking, let's do some chipping. Let's just get a couple little pieces in here. Basically what this is going to do is going to find corners and edges where little pieces should chip off. It'll just hopefully make it look a little more interesting with some smaller pieces in there as well. So I'll let that run as hopefully that won't take too long. Guess we'll see. And Houdini will make a liar of me every time. Make it take way longer than I thought it would. Guess we got a lot of little pieces. Got to see if they're chipped. And I bet you this is going to throw a whole bunch of crazy geometry in here and get rid of it. So let's see. Let's see. Wow, full minute. Chips are expensive. You know what? The one thing I didn't look at was the constraints, which should be fine because we're going to be deleting those by hand anyways. But let us see what the constraints they're setting up are. Wow, minute and a half. All right. Okay. That seems like a lot of things happen there. I don't really like what just happened there. It feels like a lot of weird things. I feel like this is all like way more intense in here. I'm gonna turn that off. I don't think we need that. It seems like there's just like I feel like all these cuts in here are different, are new, hard to tell. Yeah. Huh. I'm surprised that the chipping added all those fractures in there like that. It's kind of weird. Doesn't seem doesn't seem to be normal to me, but okay. Anyways, we'll go from here. So we got our DOPNet, we've got our rigid body solver here, we got gravity, we got everything going. If we hit play, it's going to just all fall down like so. Pretty quick. I mean, pretty impressively quick actually. That's 8 frames a second. I mean, geez, it's darn near real time. There we go. And he's done. He's down for the count. Okay. So now comes the scary part. We need to worry about those constraints. Constraints are always the scary part, but hopefully we'll get through it without too much pain. Let's just look here and see what this is making. It's making a glue constraint, which isn't surprising. It's using a search radius here. If we were doing this on our own, there's a couple different ways that you could create your own constraints and things like that. Maybe another day I'll kind of go through that in a little bit more detail. But this is a pretty straightforward, basic, glue constraint setup. We're not gonna have to worry too much about these things, but yeah. So the most important thing to know is that it's called glue. And if we go to our constraint geometry, we can see that on the primitives, it is named glue for the constraint name. So that's pretty much all we need to know. The other thing here is interesting. So we've got concrete fracture 2 and 3. 1, 2, 3. So, okay. So at each level of these fractures, it looks like it's creating a new constraint tag. I'm not sure why there's not a first level there. I'm not sure why there's not a concrete fracture 1 node or property there, but whatever. I'm sure it's just because maybe it's saying like what level it was created on, and the first level there is nothing that it needs to glue to. The second level is where it'll glue. So maybe that's why I'm not thinking about this properly. Or maybe it's just the COVID confusing me. Who knows? It's still coursing through my veins. All right. So let's do a constraint network. We will drop it in here. It can really go anywhere here as far as I understand, but let's do it here. That should be a little bit nicer. Let's do just typing randomly without hitting tab. glue, constraint, relationship. That's what we want. There we go. We can see that that has the green output dot. So we'll put that to the green spot there as well. Great. So now we've got this. Now, one of the things you have to do here is change this to just be glue. Why that is not glue to begin with is anyone's guess. I'm going to set these all to 1 because these properties should be coming in from this node right here. We have half-life, propagation rate, all these things. These all work as multipliers on the incoming properties or the incoming attributes. So we don't want to be taking a strength of 10,000 and multiplying it by 10,000. Obviously, that would create a completely unbreakable bond. So let's see here. So the other thing we need is the geometry source. This will be our second context geometry. There's all our red lines looking nice. And yeah, let's hit play. Hopefully nothing will fall. And sure enough, nothing has moved, fallen, nothing. Great. All right, done. That's the end of the stream. Bye, everybody. No, I'm just kidding. All right, let's do a SOP solver here. We jump in here, should be able to find our relationship geometry right at that point there. And there's all of our constraints. So one thing to keep in mind when you're dealing with constraints is that because we're doing RBD here, we're doing bullet, we have a packed geometry object coming in, right? So this RBD configure node is packing all of our geometry up into packed fragments. So you can see here we have 904 packed fragments. And if we come over to our, hit I here just to bring this up. So we've got 904 packed fragments. If we come over to our constraint geometry, you can see also we have 904 points here. And those points correspond to the points in our fractured geometry, all individually, independently named. They have all unique names, and that results, in that kind of setup there. So let me just bring up a null object here so we can see that maybe even a little clearer. So here is our network here. So we've got all of our points. There they all are right there. All of those correspond to our different geometry nodes, which if we look here, we have the name. I'm sorry, not geometry nodes, but geometry pieces. And so you can see here's all the pieces that those relate to right there. Same names as the packed ones are at the other one. But these primitives here are the constraints. So basically the primitive tells it that these two pieces are locked together, more or less. So what I am going to do is, let's see. Let's do this. Let's do a couple things here to tweak these constraint geometries. Let's have him have a fall off here. So I'm just going to do an add to create a point to compare this to. So let's do 1 point. Let's hit enter. I'm going to do that, and I'll do it up here because that's actually geometry. We can see it a little better maybe. No. Not the easiest thing in the world to see, but that's okay. All right, so let's have it start, from up in this direction here. Maybe we'll have it start on this side, and we'll have it fall away this like this. So that'll be our point that we're going to. So we'll do distance from geometry, sure. Let's bring in this constraint geometry and this should set it to, we'll set it to points. This should set a distance attribute here. Sure does. Great. And I will bring this even a little closer just so we have like a reasonable start point here to go for. Actually, well, there's a couple different ways you could do this. You could do this with a distance along geometry and have it start from a closest point that you could set in a group or whatever. You could do this distance from geometry, which is literally just going to be the distance between them. And you can see that that attribute is colored here. Let's see here. Distance. What was the other one? distance from target. Yeah, it's basically the same thing, I believe. Nope. I see. It's from an origin here, so you could do a few different things. But that's fine. Let's just do it the way we had it here. We have a point, distance from geometry. Great. So now these all have their own, distance attribute here, and we can do a couple things here. Let's adjust that. Let's do a float. Attribute adjust float. Attribute name, we're going to change distance. Let's just do a add. We can do noise. And we'll do middle and range length. Let's just say the middle value, sure, is 0. And let's turn on distance so we can see it here. So this is just going to add some noise into it, and we can adjust the element size right here. Something like that, maybe. And this is basically just setting it for the points. And then what I'm going to do is just promote this based on all these points. We could do it for technically, I guess we could do it over the primitive as well. That wouldn't be too bad. Let's see. Oh, that's no. Let's just do it to the points, and then we'll promote it. That'll be fine. All right, so we've got this here. Distance, great. And what I can do is adjust this. Or I can adjust this right here, the range length, and that will push this more or less around. So let's do it to maybe like 2 and no, let's do 1.5. That'll be great. And then let's take so what we'll do is we'll do an attribute promote, and we'll go from point to primitive here. Now our distance is a primitive attribute, so it should be the same across the entire primitive, obviously. So there's our distance right there. Then we'll do a primitive wrangle. Like so, and we'll just do a, let's see here. We'll just do a do dist equals let's use the dist attribute. So we'll do fit at dist, say, I don't know what the minimum and maximum are here, so let's take a look at that. Minimum can be 0. Maximum is like 8. So we'll do 0, comma, 8. And then what I'm going to do is set this to be like a frame number. So let's do frame numbers between, I don't know, 24 and 144. So let's do that. So we'll do 24, comma, 144. Basically what I could do there is once the frame number hits or goes above that number there, it'll just cut them out. It'll remove them basically. So it'll be a pretty simple process to do once we're in there. So let's look here, distance. And what I could actually do instead of doing f distance, I could do instead, I will do I at start frame, and we'll do this. I think that's the right. No, what is it? Sorry. Not thinking straight right now. Is it round? Oh, R int. That's what it is. Technically, that's not right, but that's fine. Whatever. All right, so there's our start frame for these. You can see that they're all slightly randomized, but looking pretty good overall. All right, so this will be going to call this I can type. Just so we have a little more clarity there in what's going on. And let's put this back into here. And now we should have all of those parameters in our simulation. Let's just hit that. And let's go in here and see if we can't take a look at this. And sure enough, there's all of our start frames right there. So let us now do something with that. Let's say that we will do a prim wrangle in here. So this is in our DOP. This is a geometry context inside of a DOP network, right? So this is SOP within DOP, basically. So this is going to allow us to do SOP operations frame by frame over time. So that's why that's why this will look the way it does. So I think this should work. Let's give it a shot. So let's do an if statement. If, let's see, at frame, capital F, because I believe that's the standard that they've written. So at frame is greater than at start frame, which is my attribute that I've set down here. And I will do some curly brackets like this, and I will do remove prim. And so we need to have the geo handle, which will be 0 in this case, the prim number, and points, int and points. So actually, no, I'm not going to do the and points. So I'm going to just do 0 at prim num and then 0. So let's do that. 0 at prim num, because we want to take the current one that we're looking at, which is the current primitive number, and we want to not take the points. So we'll do that because we don't want to delete the points from this. It should be seeing that basically. So let's see. I'm also going to put an output here. This should output that. And it'll make sure that no matter where our flag is in here, it should remain. So let's give that a shot. Maybe it'll work. I don't know. Kind of scared. Oh, yeah. Oh, yeah. It's working. It's working, guys. Cool. We got some crumbling. So the neat thing here in all of this is that this collapse is completely procedural, right? I mean, obviously it's procedural because we're in Houdini, but we didn't hard code anything in, right? So if I wanted this to go in another direction, the beautiful thing about this is that I can take this point and move it literally anywhere. So if I want this to crumble from the bottom to the top for some reason, oops, I could just turn this off. Actually, I could add another point in here and we'll just have it start from the origin just like that. And that should now adjust all of this. It should all change around based on that point. Because I believe we still just have one point here. Yep. Sure enough, let's just double check this here. Make sure I'm not going crazy. Blue's up here. Now blue's at the bottom. Perfect. All right. So now if we come over here to our DOPNet, this is going to collapse. It's going to break up in a really weird way from the bottom to the top. So the bottom is going to break, and then it's going to start collapsing up at the top. So that's a way different look, obviously. But there you go. That is how you do something fun like that. So it's kind of neat because we could actually have, all sorts of different, you could do something where you had where you could wedge out a bunch of different options for where that start point is to see kind of what that's going to look like, and have it just randomize a vector that's within a certain range or whatever, and just have it stick a point somewhere randomly using tops, something like that. So there's a lot that you could obviously do with this because it's procedural. There's nothing that's going to break, or there shouldn't be anything that's going to break based on. Sorry, my windscreen is falling. Based on where how you do this. So something to keep in mind. But we can obviously push this a little bit further. But so what you might be thinking now is, hey, this is not the high quality geo. This is just really rough, nasty looking geo. And when we simulate it, it all just kind of collapses and it's all real flat and looks super Voronoi and dumb. So what's the deal? And the deal is that we need to just adjust some things here. So we have our RBD configure here, right? So let's do a transform pieces like so. And we will take in the geometry to transform, which is this main geometry here. And then we need the template points. We also need rest points. So what we can do here is we can take our rest points from this node, I believe. Should be fine. There we go. Yep. And now we can see this is our high quality geometry, right? So we're back to looking at high quality geo. If we look at exploded view here, let it go apart, break apart. Sure enough, there's our exploded view. It all looks nice and wavy and high res. Cool. So now what we need is, oh, actually I did that the wrong way. What we're going to do is we're going to object merge just this RBD packed object. In fact, I'm going to reset this because we'll resim it, but let's just call this packed Rhino. Make sure this is still working fine. Working just fine. All right, I'm going to switch that so that it's at the front of it that it's falling off of. So we'll do the front point. And so this should now output, we'll call this, we'll just do star Rhino star because I know that that's what I want. I don't need the ground plane. So now coming out of here is 904 packed fragments. Up here is 904 packed fragments. So we've got nice continuity between the two. And I'm just going to take the rest points from up here because I know that those will not be moving. So now we have our transform pieces here with our simulation in the middle. And what this should do is this should now transform those pieces for me. And we should see that the high resolution geometry is simming here. In fact, I'll just let this low resolution kind of go first so that we can see what this looks like since this is nice and fast. So we'll let that all go and fall apart. We can kind of look at it here. Great. So let's look at it somewhere where it's like, yeah, I don't know, right there. Cool. So there it is. It's all crumbling to pieces. Now if we come down here, we should see that, in fact, our high resolution geometry is the stuff that we're seeing here. Now this has the interior pieces. It's not low quality anymore. It's looking, quite a bit more interesting. Now, obviously, we could have fractured this more and done more with it. That's fine. But we'll call this for now. But you can see here, this is the geometry that we started with in our sim. And then this is the geometry that we're going to be using for our simulation, or for our render in this case. And, just like if you look up here, you can see that obviously this is much higher resolution. You can see all the nooks and crannies there versus this, which has no detail at all to it. So that's kind of the concept here. You can use this transform pieces. We probably should cache this out. And the cool thing about this, about doing something like this, is that if we cache this out, if we do like a file cache, all this is going to have to save is those attributes and on 904 points. So this cache is going to be super tiny. So let's just call this RBD Rhino RBD. And then what we can do is we can save this to disk because this will be nice and quick. It'll save all these ones that it already has cached out, and then it'll just go through, boom, 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 like so. And there we go. And if we want to look at these and see what these look like, here's V1. These files are 1 MB each, 2 maybe. So nice and tiny, super easy to work with. And in fact, what you could do as well is you could just do this. You could do an add and just delete geometry but keep the points. And this is going to do basically the exact same thing. There's not really going to be any difference there. Just those points like that. So if we look at this, bloop, 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 same thing, no difference. So you can just use the points if you wanted to. Obviously, this takes a little longer to move them around because you're moving around some a little bit higher quality geometry. So there's a little bit more that it has to figure out for like the viewport and stuff. But it's certainly not a slow process. And you could cache this out if you wanted to as well, and then that'll, you could cache it out at that stage as well. But really, this is all we're dealing with right here is these points. I can remove that because we don't really need to see that, but something to keep in mind. So, great. That looks good. I'll just call this null. Call this sim cache. No, out high res sim. Perfect. All right, so let's just do one more thing to this. Let's have some debris and things like that coming off of it. Let's do like a little debris source situation here. So let's do that. Let's do a geo. And let's do an object merge here. Say get proxy sim. Get that sim cache in here. That is what we're looking for. So we got our nice, oh, got a little viewport bug. What do we got going on here, guys? Little viewport bug. Nobody wants that. All right, so if you ever have this issue where you run into a viewport bug, you can just go up to help and do reset viewport. Bingo bango. There it is. Should be all set now. No problem. All right, so let's do debris source. Go. We got our points starting to work here. So let's do this. We want to do, yeah, that's better. So now this will just be the points that are actually moving, basically. So this is basically looking at these pieces as they come in, and is basically saying, hey, let's scatter a bunch of points over this, and as these pieces of geometry start to move apart from each other, let's light them up basically and say, hey, these are moving now. They've broken apart. They're starting to create debris. So that's what you're seeing here. So as these pieces move apart from each other, it'll be creating a debris kind of source point attribute here. So yeah, we can just do something like that. That looks good. Great. I'm going to turn up the cache here since I don't want my cache to go away because this is like a little simulation that's going on inside of here. I'm not sure if it's a pop network, what they're doing in here. It might just be a solver. It might just be a SOP solver. Let me look real quick. Yep, just a SOP solver. I probably looked at that when I did one of the Mardini things I used a debris source for. All right. So let's just looking at this, making sure it's looking good. Yep, seems good to me. Great. Um, this is the scatter information here. So we have just, similar stuff to normal scattering things in Houdini. Density scale is at 1,000 and the max points are at 1,000,000, which is fine. That'll make sure that it stays to like 1,000,000 points that are scattered all over it. Let us do this. Let's do a pop network. Ooh, excuse me, getting a little tired here. Let's dive inside of this here and let's source this from points. Just see kind of where that gets us. We should have particles coming in here. Yep. Do we do all points? Maybe not. No, that is crazy. All right, so let's just do points. I don't know. Let's do a little bit more. Let's do like 20, maybe 20,000. Right. Let's also bring in this as up as their second context here, and we will do a static object for collisions here. What I can do is do op, do this op input path, because this needs to be a stop path. So let's do, I think that's what we want. Double dot one, I want to say. Let's see. Are we right? I think so. I think we are. Let's just do a merge here. And also a ground plane. You can stick those both in there. It is not moving. So we want to use deforming geometry. I think that will do it for us. Let's see here. Basically don't want any bounce. Let's turn the bounce off here. We don't want any bounce. We'll do like the tiniest bit so it's not completely nothing. I think this has like an insane amount of bounce. Let's turn that way down. Cool. Let's see. Neat. Let's see here. Pop solver. Let's just make sure we have sleeping on, so that if anything would come to rest, it will stop being calculated. You know what? The other thing I want to do is probably turn up the friction on these things. Those have zero friction. All right, so let's do like 7.5. Let's try that. Just sliding everywhere. Okay, cool. I'm going to turn off the guide here. We don't want to see that. Let's also stop coloring these. I don't want to color these. We don't need to have a color property coming in here and messing with everything. Kind of gets a little confusing to see. So let's take a look at this now. They're falling asleep, actually. Let's just take a look at that. They might be sleeping too soon. So let's see if any of these fall asleep here. Obviously don't want them to. Oh, I think I know why. There's no gravity. Whoops. Forgot one major thing here. Gravity. I want things to fall. There we go. That explains it. Let's do this. We'll change these back a little bit. Maybe give them a little more bounce. We don't want to go too crazy. And let's set the friction to 0.5 so it can move a little bit. No wonder that was acting so weird. There's no gravity. Let's see how this looks. Add a few more particles in here just to kind of see if that stops some of our. Nope. Do it. Let's see. Just kind of hoping to get some of the stuttering out of there. Let's see here. I'm actually going to go a little less with the sleep delay there because I think we want some of these particles on the ground to actually be asleep. Cool. It's looking kind of interesting. And in fact, now let's see here. We'll just do pop so that only the particles come out here. All of our particles bouncing around. It's a little weird, but whatever. It's at the end. You probably won't even see that. So let's see here. Let's take a look at what this looks like. And with those particles, obviously, what you could do too is you could have you could copy some geometry, some small little geometry onto that if you're getting close enough to actually see those little particles and stuff that are coming off of there. So that might be something that you would want to do. Um, from this debris source, I think it's just a little longer. Trying to think here. Yeah, I can reset this. Just let this go again. Should allow it to pile up maybe just a little bit more. You know what I could do as well here is actually just write a little bit of code here that if so what these things should be doing is there should be a point at which they become, let's see, is it stopped, I think? Yep. So what I could do is if it hits stopped as 1, I could set the life a lot higher. Can't remember if there's a way to do that easier, but I know that'll work. So I'll just do a pop wrangle. Just say if at stopped equals 1, at life equals, I don't know, 100. Sounds good. So let's see. So that should mean that if they stop, they won't die. Let's see. What I'm going to do actually now, as a matter of fact, is I'm going to come back, set this back to 1, just to make sure that they're not all sleeping and then not dying, because that's going to just be insane. We don't want that. So let's see. Let's see what happens here. Got some sleeping points there. Yep. All right. So they do need to be a little bit longer for the sleeping just to see what's really happening here. But let's do 1.5. Unfortunately, this pop network isn't seeing that change to that debris source node as a change upstream. So I'm having to hit reset simulation just to make sure that it actually gets us back to an initialized state for that simulation. So we should see that all these red ones will stay and they won't be deleted. Sure enough, they're all staying. So I guess the reason for that is like if you have particles that are moving still and they kind of die out, they could almost be like dissolving or something like that. It could just be like dust that's kind of breaking up and dissolving. But maybe these ones that have actually stopped are are something that you might want to actually have as like a stick around to show as like some sort of little extra rubbly bits. Just gonna color these so that they're not red when they come to a stop like that. But let's take a look at these particles. Actually, I'm going to go to the RBD here and just look at the proxy instead of the full resolution one because it'll play back much nicer. So there we go. There's a little custom RBD simulation. Obviously, you could push it a little bit further if you wanted to. Oh shoot, my particles went away because I didn't set this high enough. Let's set this to 48, sure. And I'm going to do one more thing. I'm going to come in here, do attributes, add to inherited velocity, and just do like the littlest bit of randomization here, just so that they're not all moving exactly the same direction. Let's see how that looks. Should just help break them up a little bit more so that they're not like these like streams coming off of it. They're a little just more randomy. In fact, I could probably do that even a little bit more. I could probably do 0.1 like so. Yeah, that's better. Less stringy looking stuff. So let me just do a grid as well, just to have a ground plane here. Five sounds good. Let's hit play. It's so dark. Let's render out a little flip book here. And I think this will be where we'll end this stream for the evening. Still getting my sea legs back underneath me here, as far as getting back to normal working days and all that kind of stuff. But I really appreciate you all joining me tonight for a stream. Hopefully, this was something interesting. And was something that you could kind of take and bring into your own projects and things like that. Obviously a lot of different ways that you could control these RBD simulations like this, crumbling and stuff like that. But this is just kind of a really basic starting point, something to just kind of get your, sink your teeth into a little bit, think through, and hopefully it'll kind of get your brain going into some other options that you could do as well. But yeah, that's that is our low quality proxy here. Unfortunately, it looks like it was still emitting a little bit in the middle there, but probably something we could fix if we wanted to. Let me just go back here to this, do the high res version as well. I'm just gonna hit that, do this here. You can get another view of it. So here comes our high-res version of the same simulation, just a little more detail in our model. But yeah, so thank you for joining me tonight. Hopefully got something out of this, whether it's learning a little bit more about constraints, understanding maybe sourcing some particle debris, as something is falling apart like this, keeping alive the particles when they hit the ground, the material fracture SOP itself, which is kind of interesting to look at. But one thing just to notice too here before I sign off for real this time is that even though this geometry is slightly different than the geometry from the from the proxy, really you don't notice too much of a difference. Maybe if we were close into it, we might see some penetration with the particles and things like that. But for the most part, you don't really lose out too much on that. And in fact, what I probably would do as well is add in some dust and things like that would further obstruct what might actually be happening here. But, just something to kind of notice while you're looking at this. But yeah, so there we are, folks. Thank you again for joining me tonight. I will be back to this next week as well, as long as I don't get another bout of COVID, I guess, but that I don't think is even really possible. So again, thanks for joining me this evening, and hope to see you next week. Have a great evening and a great rest of your week. See ya.